Hello and welcome to Colin Cymru. This is going to be A2 Statistics, the normal distribution. My name is Grant McKenzie and I am a teacher at Porthcawl Comprehensive School. So moving on. Okay, so we're going to talk to you about the normal distribution. As I've got here is the schema learning from the WJC specification. I'm also going to sort of talk about the fact that I'm going to be using the white calculator. The white calculator, as it's known as, or I think it's a newer version out now at the moment, where you would be pressing sort of menu 7, and that gives you the 3 possible options. You've got the normal PD, which is the specific value, the normal CD, which is the cumulative values, and also the inverse normal. I'm going to go sort of through the first couple of slides. I'm going to go through the basics, making sure you understand where everything comes from, and then I'm going to get into some questions. Again, I've tried to do one from the WJC and then the rest of them I've taken from different exam boards. So you get a flavor and then you've got more questions that you can look at from the WJC with the papers that are coming through. I'm also going to say this is the last in 2024. So if you do want to have a look at some pure videos, some mechanics videos as well, if you go to e-sgol or Colin Cymru website, there are various videos you can look at for AS and A2. The AS, obviously, if you're going to be resitting in the May as the exams are coming in the next sort of 10 weeks. Okay, so we're going to say that X, which is my random variable, and that belongs to the normal distribution. And again, it's got 2 parameters. You have mu, which is the mean, and then you have delta or delta squared. So obviously the value on its own is going to give you the variance, and the square root of that is going to give you the standard deviation. A lot of the times you will see it written as a number squared. That number on its own is the standard deviation, and then if you want to square it, it's the variance. If you just see a number on its own, you have to square root it to get the standard deviation. It is important that you understand where that comes from and what to do with each of the different questions. Okay, so the normal distribution creates this beautiful sort of bell-like curve. Okay, in the center of it is going to be the mean, and then you have the standard deviation either side. Now 99.9% of 3 standard deviations either side is the sort of the curve is within 3 standard deviations of either side. The whole of the total area underneath this curve is equal to 1, which is why the sort of the element of probability comes in. You're going to be asked questions where you will have been given the mean and the standard deviation and then work out the percentage or work out the probability of obtaining a value. Then you'll be given questions, and there'll be real life questions. I've tried to sort of mix it up between the two, where I've got some scenarios that are real life, and then there's just scenarios where it is a bog standard question. And then there's going to be some questions where they've given you the mean and you have to work out the standard deviation given a value. They've given the standard deviation and you have to work out the mean. And then there is going to be a situation where there are 2 values given to you without the mean and standard deviation, and then using simultaneous equations you have to look out for both. The reason why I've got this bell shape in histograms, because this is what they are, is because you need to spot it. Okay, they'll ask you to identify why you think, and it's either going to be a chart or it's going to be a table of information, a table of data, what makes this look like a normal distribution, and then they'll give you the values themselves. Okay, that seems to be the standard sort of with this. I know you know how to calculate standard deviation, that's from, and the mean, that's from sort of AS. So if I move on to the first one, I'm going to then, I've written down a couple of salient points that I want to sort of do, but this is from now. Okay, so I thought I would try a few of these questions. There's no context to it either, it's just telling you that X belongs to a normal distribution of 20 and 9, or you can write it as it's a normal distribution 23 squared. So you can see here that the first option is telling you the mean and the variance, and the second option is telling you the mean and obviously the standard deviation squared. Either way, we want the 20 and we want the 3 when we substitute these into the calculator. Notice with the first one, it's px is equal to 19. And again, what you can do is you can stop at any time or pause the video Try these questions yourself, and then, as I say, let me go through it and you can see where I'm getting them from. So the first one, px is equal to 19. I would do menu 7, and then it would be normal PD, which is the first option. And then I would put into the calculator 19, the standard deviation is 3, and the mean is 20, and it will come out with a value of the 3 sig figs, because let's be honest, everything we do is written to 3 sig figs, is going to be 0.128. For the second option, we would then, these are cumulative, so if it's got an inequality, they're going to be cumulative. So we would go menu 7 and then number 2. And notice if we've just done 19, the standard deviation and the mean are still already programmed in there, but it's asking you for two separate things now, the lower and the upper bound. Like I said to you before, that bell-shaped curve goes off to and tends towards the axis, but never actually reaches it. So what we would do is the lower value we would put as 25, and then the upper value we would do 1 times 10 to the 99, or a very, very large number, okay? Make it sort of like stupidly large compared to the mean. So 5,000, as I said, I would prefer to put 1 times 10 to the 99, put in the value, and then you will get an answer of 0.0478. On the flip side, we would then do when it is less than or equal to 22. So this is now our upper value, and our lower value is going to be minus 1 times 10 to the 99. And of course, the standard deviation is 3 and the mean is 20. So then this is going to be equal to 0.748. And then the last one, we have a lower value of 19 and upper value of 22. Mean the standard deviation is 9 and 20. And then this is going to equal 0.378. Those are just there to show you how I've got them, okay? Here we got a little bit of something slightly different, where you are told that the probability of x being greater than a is going to equal to 0.2. So if we were to sort of draw this bell-shaped curve, it would go up, round and down like that. So there is 20%, which is shading in. Well, the calculator, just like when you do the inverse of most things, can only take one option. So it's taking the lower value. So when you do the inverse for this, when it's a greater than, you would do inverse minus 1 of 1 minus 0.2. So this would be menu 7, and then it is 3, so it's the inverse normal. This is basically when you've been given the area of something. Again, the mean and standard deviation are the same, but you've been given the area and you want to know what the value is. So because it is greater than, it's taken the sort of left-hand side. Because the calculator can only take one element, it takes then the opposite of that. So you do 1 minus 0.2, which is 0.8, and that will give you a value of 22.5. 22.5, and then px is less than c is equal to 0.4. So 0.4 would be on this side, so we don't have to do anything other than put the inverse value of it, and then that's going to be 0.4, and that will give us a number of 19.24. And that sort of makes sense. If you think of the mean, so the average, which is 50%, is 20. 40% is going to be less than that, and then obviously the 80% or the last 20% of it is going to be 22.5, which sort of makes sense. I found the question as well, and I thought it was quite nice, where it says find b such that the probability of 20 minus b is, x is greater than 20 minus b, but is less than 20 plus b, and that gives you a value of 0.5. So this is basically an interquartile range. The upper part is the upper quartile, the lower part is the lower quartile. So it said the upper quartile minus the lower quartile is equal to 0.5. That's the central spread. Okay, so you take one element of it. I'm going to say that the probability of x less than 20 plus b is equal to 0.75, because that is the upper quartile, which is 75% of it. And then once I've done that, I am going to then put in the I inverse of 1 minus 0.75. No, I'm just going to put 0.75 in. Sorry, I don't need to sort of worry about that. The inequality is in the right direction. So I'm going to put I of 0.75, and I'm going to get an answer of 22. And then I'm going to say, well, 20 plus b equals 22. So b equals 22 minus 20, which is equal to 2. So the value of b is, using sort of 22, so then this is saying that between 18 and 22, it is 50% of the information. Moving on to the sort of the next part I want to explain to you. And then, as I said, I'll answer the questions of the different exam boards, is the standardized tables that you use is when Z belongs to the normal 0, 1. So you have 0 being the mean and 1 being the standard deviation. Okay, and then you can use those tables to help you, but you can also use it and put it into the calculator. Okay, you can do all the things that you can on the tables with the calculator, and it just makes it so much easier where it's all in one place. Then if you need to calculate Z, or if you've then worked out what the Z is, and this is mainly for use of when you've trying to work out the standard deviation given the mean and another point, or whether you've been given the standard deviation, you need to work out the mean, or if you have to work out both. And then you would use the formula x minus mu over standard deviation. Now this is really important as well as a formula, because when you move on to hypothesis testing, this is one of the ways in which you can sort of work out using hypothesis of the normal. Okay, so it's really important that you are aware of this formula and this and how to calculate them. I would have put it on the other slide, but there wasn't much space. I think then we've gone through the sort of the main characteristics of a normal, other than to say, there was one more thing, other than to say, so you have your bell-shaped curve like so. If you change the mean, what happens is the curve will move in either direction. So if you increase the mean, you'll move it in this direction. If you decrease the mean, you'll move it in that direction, which makes sense. If you then change the standard deviation, what happens is, because the area under the curve is equal to 1, to increase the standard deviation, so if you increase standard deviation, SD for standard deviation, or I'll put it as delta, what happens is, if I go and put a normal bell-shaped curve into here like so, what happens when you increase the standard deviation, you make it wider, so it gets a little bit higher here, but it flattens it out, that section there. Okay, so it reduces the height. That's if you increase it, make it wider. If you then decrease it or make it smaller, so if you decrease or make smaller, then what happens, again, if I sort of show you via this diagram, so it goes up and then down. If you decrease it, make it smaller, then it gets smaller values here, but it gets higher up the top. Then it comes down like so. Okay, so if you make it smaller, the height of it increases, so the end bars go smaller again, but it gets bigger in the middle. If you increase it, as in open it up to a wider value, then it will flatten out and bring the sort of the peak down, and the ends are going to get that little bit bigger. Okay, it's important to know the mean just changes. It's the same shape, it just changes along the x-axis, whereas the standard deviation makes it smaller on top or larger on top. Okay, let's get on to our first. So this is the GCSE question, and then we'll sort of work through it. So we have Arwen collects data about household expenditure on food. It records the weekly expenditure on food for 80 randomly selected households from across Wales. You can see obviously there is the cost along the top and then number of households he's got then underneath it as a frequency. Explain why a normal distribution may be an appropriate model for the weekly expenditure for food of this sample. So if I put A there. So again, if you have a look at that, you're thinking of that bell-shaped curve. So you've got the central value here, which is the biggest, and then it's decreasing either side of it. So I would say something along the lines of symmetrical, taller in the middle, getting smaller as it moves out to the ends. To the ends. And obviously if you want to put in bell shape, then that's fine. So as your 1 mark, and then it says RON uses the distribution N6415 squared. So they've written it as standard deviation squared to model the expenditure on food. Find the number of households in the sample that this model would predict to have weekly food expenditure in the range. So we need the probability first of all. So if I go B part 1, the probability, actually I like to write down what this is. So X belongs to the normal, and if they haven't written it in this way, I probably would have squared, so that then when we're doing P60 X 70, so I would menu 7 and then it's cumulative again, so it would be number 2 for the normal distribution, CD. Your lower value is 60, your upper is 70, your standard deviation is 15, and then your mean is 64. Type that in, and you will have a value of 0.26055. And then because there were 80 random households, then you would do 0.26055 times 80, and that gives you a value of 21. Then for part 2, it's asking for px greater than or equal to 90, and then it's the same thing. So it is CD, so your lower is 90 and your upper is 1 times 10 to the 99, and then standard deviation and the mean is already sort of put in place. So then this is going to be 0.041518, and then you would do 0.041518 multiplied by 80, and that gives you a value of 3. So we've done the first part for 4 marks. Now C, part 1. Use your answers to part B to comment on the suitability of this model. Well, let's compare the model. So if we do for P60 X 70, we have in the table 18, in calculation we have 21, and then for px greater than or equal to 90, in the table it is equal to 6, and in calculation it is equal to 3. So I would say that this is not the best model because of the fact that 3 away is quite high. If it was only 1 or 2, then I would say that not the most accurate, could be accurate or along those lines. After comparing, could be more accurate. Then it asks you for part 2, explain how RN could improve the model by changing one of the parameters. Well, as I said to you before in the previous slide, if I was to change the mean, it would just move it across. Well, I don't need to move it across. I need to actually sort of flatten it down. So in flattening it down and making it wider at the bottom, if I increase the standard deviation, that would give me slightly lower than 21 towards the 18, and again slightly sort of lower. I've got 3 at the moment on the bottom, so it'll come up that slightly and it'll come towards the 6. So here I would say increase the standard deviation. for the 1 mark. And then part D, if I put over this side, Arwen's friends, Colleen, wishes to use the improved model to predict household expenditure on food in Northern Ireland. Comment on this plan. I would say may not be suitable. Because of the fact that weekly expenditure compared to Northern Ireland could be different. Expenditure in NI could be different. There's different demographic, there's different areas, so therefore I would think that she would need to sort of create her own. Moving on. Okay, so here we have the mass in grams of plums of a certain kind have the distribution N5518. First thing for me, I would change that so that X belongs to a distribution of 55 and then square root of 18 squared. Just so that I'm aware, and when I type it into the calculator, I'm putting root 18 in there for the standard deviation, because that's the variance at that point. I'm going to stop sort of explaining all the different values in the calculator now. I'm just going to sort of go through the questions. I think for the first one it was appropriate, but now it's just going to get tedious if you hear me saying lower value, upper value that you're going to be putting in. So question 1, find the probability that a plum chosen at random has a mass between 50 and 60. So for A part 1, the probability that it is between 50 and 60 grams, X and 60 is equal to 0.76. And again, this is just taken from the calculator. Sorry, 761 to 36 figs. Part 2, and this is a new element. So the heaviest 5% of the plums are classified as extra large. Find the minimum mass of the extra large plums. So this is looking for the inverse. So you would do menu 7, 3 for the inverse normal. And if you remember what I said, so because Px is greater than or equal to A, and that is equal to 0.5, 0.05, sorry, this is 5%, and that's equal to 0.05. You would use these values in the inverse normal, and then you would do 1 minus 0.05. If you remember previously the sort of bell-shaped curve, and you're talking towards the sort of the furthest end, you would have to do 1 minus that, so it would be 0.95. And then substituting that in, it would give you 61.97, which is approximately 62, and we're looking at grams. For part 3, and I'm leaving all this space then for question 5, the plums are packed in bags, each containing 10 randomly selected plums. Find the probability that a bag chosen at random has a total mass of less than 530 grams. So again now, since we're putting a normal has changed, or the normal distribution has changed, instead of being 55 as the average, we would do times that by 10, and instead of 18, we would do 180, and then it would be the square root of 180 squared for my standard deviation. You're then asked the question, the probability that X is less than 530, which typing in the calculator would change the mean and the sort of standard deviation, and then putting in the upper bound as 530 and the lower bound as minus 1 times 10 to the 99, last time I promise, and that would give you a value of 0.0680. For the next part, we're going to use, like we did with the second slide, sort of the inverse, because we're looking for the standard deviation. So we're going to have to normalize this because we have no idea what that could be. So the mass in grams of apples of a certain kind have the distribution of a mean of 67, standard deviation unknown, is given that half of the apples have a mass between 62 and 72 grams. Okay, so again, if it's half the mass, then you are that sort of between that value. then what you're looking at is the interquartile range. So I would then pick one of them. So you can pick 62, which is going to be the area under the curve is going to be 0.25 because 25%, or the 72, which is the one I prefer because then you're sort of less likely to deal with negative numbers. In this case, I don't think you would either. So you would say that the probability that x is less than 72 is equal to 0.75. And then you would standardize these values and say that z obviously belongs to n01, and then the inverse of 0.75 is equal to 0.6745, and then use the formula that is z equals x minus mu over the standard deviation. I change color so that it doesn't get sort of lost. Then substitute everything in and rearrange. So z value is 0.6745, and that is equal to 72, because that's the one I chose, minus the mean, which is 67, over the standard deviation. So the standard deviation is changed, as in it moves up and that value moves down. So it is 72 minus 67 over 0, let me rub that out. That's better, 0.6745, and that gives me a value of 7.41. So the standard deviation is 7.41. Moving on. Here is very similar to the sort of the first question we did for the WJC. I thought it'd be a nice one to do. So a market gardener records the masses of random sample of 100 of this year's crop of plums. The table shows his results. And again, explain why the normal distribution might be used for a reasonable model for this distribution. Again, if you look at the middle, it is sort of the largest one, and then it tails off. So if we say for this one, let me turn to black. For part A, symmetrical, high in the middle, tails off at the ends. For part B, 1, we have x belongs to the normal, and it is 47.5 and 10 squared. Find the number of plums in the sample that this model would predict to have masses in that range. So we would put in P35, M45, and that is going to give you, just typing it into the calculator, 0.296, and then you would do 0.296 multiplied by 100, which is 29.6, approximately 30. And then the other one, which was PM less than 25, and that is 0.0122. So 0.10122 multiplied by 100 is equal to approximately, well, it's 1.22, which is approximately 1. Use your answers to part B1 and B2 to comment on the reliability of the model. If we then say table and then calc, very similar to what we've just done. For 35 to 45, we have 29, and then we have 30. And then for the other one, which is less than 25, we have 0 and 1. Therefore, very close and reliable. Then the last one, the market gardener plans to use this model to predict the distribution of masses of next year's crop of plums. Comment on this plan. So if I put this here for part C, and then part D, external factors may affect factors may affect crop, e.g. weather. So may cause a different distribution, e.g. weather may cause a different distribution, both in a positive and a negative way. Moving on. So here is, again, sort of looking at the random variable t is normally distributed as mean, mu, and standard deviation delta. It is given that the probability of t being greater than 80 is 0.05 and the probability t being greater than 50 is 0.75. Find the values of mu and delta. Okay, so because we've gotten very little information, we're going to say that x belongs to a normal 0, 1 using the calculator. Sorry, not x. We're going to say that z, and then we're going to use the z values for this. We're going to say that the inverse of 1 minus 0.05, because it's greater than, which is going to be 0.95, is 1.645, and also the inverse of 1 minus 0.75 is equal to 0.6745. I only did that because it was greater than. You could treat it as just putting it in as 0.75. Both ways would be acceptable. It's just I prefer to do it this way myself. You are going to be using that z is equal to x minus mu over delta. So with the first equation, we would have 1.645 equals, and then the first one is 80 minus, we don't know what mu is, over delta. And then the second equation is minus 0.6745, and that is equal to 50 minus mu, and that is over delta. Now, personally, what I did was I swapped the deltas and substituted them together and then equated them. So I had 80 minus mu over 1.645, and that was equal to 50 minus mu over minus 0.6745. With a little bit of rearranging, I was managed to get mu. Sorry, that should be a 50 there. I don't like the look of that. Bit of rearranging, I was able to work out that mu is equal to 58.7, and then substituting this back into for delta, so I put in delta equals 80 minus 58.7 divided by 1.645, and that gave me an answer of 12.9. So for this question, the t belongs to a normal 58.7, 12.9 squared. And then moving on, 2 more questions to go through. First one, Jaya writes a computer program that randomly generates values from a normal distribution. He has set the mean at 40 and the standard deviation as 2.4. Find the probability that a particular value generated by the computer program is less than 37. So A will say that x belongs to a normal 40, 2.4 squared. Probability that x is less than 37, and that is 0.106. Part B changes the mean to m but leaves the standard deviation as 2.4. The computer program then randomly generates 2 independent values from this normal distribution. The Probability that both these values are greater than 32 is 0.14. Find the value of m given your answer to 2 decimal places. Well, to get 0.16, we're going to square root that, so we can say that it's 0.4. Sorry, 0.04, 0.16 equals, that's actually 0.44. And then we would use, because we're trying to work out the mean, m, we would use z in this case. Normal, and then 0, 1. So we're back on our calculators. We're looking at the inverse of, because of the fact that it is greater than 32. So we're looking at 1 minus 0.4, which is 0.2533. And then we'll go back to using z equals x minus mu over our standard deviation. So we would have 0.2533 equals 32 minus mu over 2.4, not 2.2, 2.4. And again, you rearrange that, move that over to the other side. Mu is going to be 32 minus 2.4 times 0.2533, so that mu is equal to 31.39, which is approximately 31.4. And coming to our last question is the weight in grams of beans in a normally distributed with mean mu and standard deviation of 7.8. Given that 10% of the tins contain less than 200, find the value of mu. So another one like this to sort of finish off. So we would then say that the Z belongs to N01. We are saying that it is given that 10% contains less than 200. So we would do the inverse of 0.1. And that is equal to minus 1.2816. Using our z, which is x minus mu over our standard deviation. We now know our standard deviation is 7.8, so we'd have minus 1.2816. That is equal to 200 minus mu over 7.8. And rearranging this to have the 7.8 goes up, becomes a minus, go over to a plus. You would have then mu, if I put it under here, is equal to 200, and then that would be plus 1.2816 times 7.8, and that would give us 200 plus 9.99, which is approximately 210. I hope these have been really useful and that you can use them with revision of exams. I'd like to thank you very much for watching this video.